Hello everyone, we're going to sort of do a little extension here, solving some equations, solving some systems of equations. I want to practice using the least common multiple or just finding a way to get rid of some fractions to help clear these up. Sometimes they can get really messy, and this is a strategy you can use when you end up with equations that are sometimes more complicated than you feel like dealing with. So what I'm going to do in this first problem, this is just a linear equation, and what I'm going to do is look for a common multiple between the denominators, so 7 and 2. You can always multiply them together to get a common multiple. That won't always necessarily be the least common multiple, but in this problem, the least common multiple between 7 and 2 is 14. So I'm going to multiply both sides by 14. And when I do this, I'm multiplying everything in the problem by 14 with the goal being to remove all of these denominators. So when you do this, you can multiply 14 over 1 times 3 over 7 two ways. You can multiply 14 times 3 and get 42 over 7 and get 6. Or, probably easier to do it where you first do the 14 over 7. 14 over 7 is 2. 2 times 3 is 6. But we're practicing our mental math skills a little bit, practicing multiplying numbers times fractions. When you multiply 14 times 3 over 7, you get 2 times 3, which is 6x. 14 times 2 is 28. 14 times 1/2 is 7. What we've done is we've cleared out all those fractions. We have a much easier equation to deal with. I can subtract 6x on both sides, and I get negative 28 equals x. Cool. Now, let's do another one. Common multiple here between 3 and 2, the least common multiple. Again, you can multiply them together in this case and get 6. I'm going to multiply everything by 6. So when you multiply by 6, 6 times 2 is 12. 12 divided by 3 is 4x. 6 times 4 is 24. So you distribute. On the right side, if you do 6 times 5 halves, first, figure that out. 6 divided by 2 is 3. 3 times 5 is 15. And 6 times 7 is 42. Now, I will get all my x's on one side. So I'll subtract 4x minus 4x. 24 equals 11x minus 42. Now it's a two-step equation. Add 42. 66 is 11x. So when you divide both sides by 11, you get x equals 6. Okay, those are just linear equations. Now we're going to find actually the solution to a system of equations, but we're still going to use this to kind of help us. You could probably isolate x pretty easily in this problem, but you have this substitution, then you have to plug that in up here, and you're like, man, this is going to get worse before it gets better. So what I'm thinking is, let's clear this second equation of fractions, and the way I'll do that is if they have a denominator of 7, I'm going to multiply everything in the problem times 7. So my first equation isn't going to change, but my second equation now, I'm just going to like say, look, I'm redoing this problem. There's my first equation. My second equation now, I'm going to do 7x, 7 times 1 is 7, 7 times 1/7 is 1y, and then 7 times negative 3/7 is negative 3. This makes it much easier to isolate a variable that is useful to me. So now I have, if I subtract 7x on both sides, I have this as my substitution. So what I'm going to do is, now in my other equations, so right here, instead of y, I'm going to say negative 6x minus 6, but instead of y, I'm going to write negative 7x minus 3. Okay? In one step, I've gotten rid of all the fractions. I made this much easier to deal with. I just need to kind of go through the process of solving now. So I'll say negative 6x plus 42x plus 18 equals negative 18. That would be 42 minus 6 is 36x, and if you subtract 18 on both sides, you get equals negative 36. So when you divide by 36, you get x equals negative 1. Coming back up here, y equals negative 7 times negative 1. 7 minus 3 is 4. So the solution is negative 1, positive 4. We found x, we found y. We like to write our answers as ordered pairs. So let's try another one. Same idea. You can notice the first equation. You could probably clean that up a little bit if you did use some of the strategies we're talking about. But what I'm going to do is down here is get rid of the denominator, common multiple between 2 and 10. Let's multiply by 10. Okay, so the first equation isn't going to change. Again, I'm just going to kind of put that up to the side. And now this new equation I'm working with, if I multiply by 10, 10 times 1/10 is 1x. 10 times 1/2 is 5y. And 10 times 2 is 20. This makes it much easier to isolate x. You would subtract 5y on both sides. So negative 5y plus 20. And now I'm going to do a substitution. So instead of negative 8x, I'm going to plug in what x equals, negative 5y plus 20. And now I have one equation with one unknown, so I just got to go through and solve it. 40y minus 8 times 20 is 160 plus 8y. So you get kind of big numbers, but it's going to get better. 48y, 40 and 8 make 48y. And if you add 160, you get 144. 160 minus 16 is 144. Now, the last thing you need to do, divide both sides by 48. And you're going to get, hold on, divide by 48. There you go, divide by 48. 3, y equals 3. Nice. Come back up here. X equals negative 5 times 3 plus 20. Negative 15 plus 20, x equals 5. So as an ordered pair, let's say 5, 3 is the solution to the system. Okay. It's not that you can't do it with the fractions, it's just that it makes it much easier to get rid of them. So that's what I'm trying to teach you how to do here. Let's do a few practice problems. I think I have 4 of them here, and I know we'll get at least one weird one. But if you'll notice, both of these equations are pretty gross. So what I'll do first, although they equal 0, so this might be interesting. Let's multiply this guy by 4. And we'll multiply this guy by, the least common multiple between 10 and 4 would be 20. So when you multiply 4 times 1/2, you get negative 2. 4 times 1/4 is 1. And 4 times 0 is 0. 20 times 1/4 is 5x. 20 times 1/10 is 2y, and 20 times 0 is also 0. I think I'd want to get that y by itself. So y equals 2x. If you add 2x to both sides, y equals 2x. Now I'll come down here. I know what y equals. 5x plus 2 times, again, I'm not writing y. I'm writing what y equals, 4x. 5x plus 4x is going to be 0. 9x is 0. X equals 0. And then 2 times 0 is 0, so y equals. So actually the solution to this is 0, 0. That's the origin. Now, why I think this is a good problem is because oftentimes we get these like no solutions, infinitely many solutions, and people think, oh, I got something equals 0. That can't be right. 0 is just a number, guys. You can get 0 as an answer. Here, x and y are both 0. It's kind of weird, but they pass through the origin. So that's where they intersect. Let's try another one. Okay, both of these have denominators of 2. So in both problems, I'm going to multiply everything by 2. Okay, so now I have negative 8x minus 2 times 1/2 is 1, and 2 times 3 is 6. 2 times 4 is 8x. 2 times 1/2 is 1, and that's also, oh, wait a minute. I got a bad feeling about this. So I didn't notice it here, but I kind of think these are going to be parallel. You know what? I'm going to solve for y in both of them. So I'm going to add y. So I have negative 8x equals y plus 6, and then subtract 6. Y equals negative 8x minus 6. That's the first equation. And if you do the same thing here, y equals negative 8x plus 6. Okay, those two lines, you'll notice, have the same slope, but they have different y-intercepts. So if they have the same slope and different y-intercepts, this is no solution because these are parallel lines. I'm not going to go any further, but I didn't really notice it here. I did notice it when I got to there because I had the 8x and the 1y and the 6, so it kind of felt weird. If you start to kind of get that like feeling like this one seems wrong, then maybe the good idea would be to solve them both for y and look at it from there. A couple more. Everything here has a denominator of 4, so I'll multiply everything by 4, and everything here has a denominator of 3. So the first equation, if you do 4 times 3/4, those cancel. You get 3x. Okay, or you can think of it as 12 divided by 4, which is 3. 4 times 1/4 is 1, and 4 times 1/4 is 1. 4/3 times 3, those cancel, and you get 4x plus, those cancel, 1y equals -1. I don't think this one, they definitely have different coefficients for x, so I don't think they're parallel. But I'll get a substitution here. I'll probably just, you know what, I could probably just subtract 4x in this one. So y equals -4x minus 1, and now I'll do a substitution right there. So I have 3x minus, instead of y, I'm writing -4x minus 1. You do need to be careful with the minus signs. Plus 4x plus 1 equals 1. 7x equals 0. Uh-oh, I got 0 again. X equals 0. And then when I plug in 0 into my other equation, I get 0 minus 1, which is -1. So this is 0, -1. Again, 0 is just a number. Oh, can't see that. 0 is just a number. So if you get 0, don't freak out. Sometimes it's better because it's really easy to plug in. I plugged it in right here and I got 0, -1. All right, last one, common multiple. There's just a denominator here, 4. Let's multiply by 4. And then this guy's got a denominator of 2, so let's multiply this guy by 2. 4 times -2 is -8. Those cancel, and you get -7y. 4 times 4 is 16. -8x plus 1y equals +16. They both equal 16, but okay, they're going to have different slopes. I think it's okay. Let's get y by itself down here for our substitution. I'll use the second equation. Y equals 8x plus 16, and now I'm going to substitute my y in. So in the first equation, -8x minus 7. But I'll plug in 8x plus 16 instead of y. Notice you just have one variable. -8x minus 56x minus 70 and 42 is 112. Okay. This would be -64x minus 112 equals 16. I hope this gets nice. 64 equals 112. That would be 120. Good. Divide by 64. -64. X equals -2. Okay. Now plug it in here. 8 times -2, -16. I get 0 again. Y equals 0. So this one is -2, 0 is our solution. Okay. So we're going to use this skill when we do elimination, but we've done a couple substitution problems with fractions. I think it's good practice. It's a great skill to have. Make sure you smash that like and subscribe button.